Welcome to The Explainer. Today, we're taking a journey to one of the most incredible places in our entire solar system, Saturn's biggest moon, Titan. It's a world wrapped in this thick golden haze, and it's just buzzing with chemical mysteries that might, just might, hold some clues to the very origin of life itself. All right, let's just jump right in with a little thought experiment. Picture this. You are there right now. You're standing on the surface of Titan, safe inside a pressurized suit. What would it actually feel like? So you step out, and right away, you know this place is, well, it's a world of extremes. And it's profoundly different from Earth in just about every way you can imagine. First thing that hits you? The cold. I mean, it is just unimaginably frigid. The surface temperature hovers around a bone-chilling minus 179 degrees Celsius. That's about minus 290 Fahrenheit. But here's where it gets kind of weird. Even though it's so cold, the air pressure, the weight of the atmosphere pushing down on you, would actually be 50% greater than what you feel at sea level on Earth. It would feel dense, heavy. So you've got this heavy air, but you feel incredibly light. The gravity on the surface is just under 14% of what we have on Earth. Every single step you take would feel slow and graceful. You could probably jump an incredible distance without even trying. And as you look around at this strange landscape, everything is bathed in this dim, orangish glow. You see, Titan gets less than 1% of the sunlight we do, so you're living in this perpetual hazy twilight. So, you've got this bizarre, freezing, low-gravity, dimly lit world. What is going on here? Well, to figure that out, we have to stop looking at the ground and start looking up into Titan's absolutely incredible atmosphere. You see, Titan's atmosphere isn't just some blanket of gas. Think of it more like a giant, moon-sized chemical factory. And it's powered by the sun, even from way out there in the outer solar system. And the raw ingredients for this factory, they're actually pretty simple. The atmosphere is mostly molecular nitrogen, just like Earth's, which is kind of amazing. But it's also got a healthy dose of methane mixed in. So what's the engine that runs this whole operation? It's a process called photochemistry. And really, that's just a fancy way of saying chemical reactions that are kicked off by energy, specifically from sunlight and charged particles zipping around Saturn. Okay, so here's how it works in a nutshell. Way up high in the atmosphere, all that energy zaps the nitrogen and methane molecules and just shatters them apart. These little fragments are super reactive, so they immediately scramble to find new partners, combining in all sorts of new ways to build bigger, more complex molecules from scratch. And the stuff that comes out of this factory, well, that's what makes Titan so incredibly cool. This process creates this just amazing diversity of organic molecules. You know, one scientific review just nails it, calling the result a chemical wonderland. And that's the perfect way to describe it, because we're really just beginning to understand the sheer complexity of what's being created there. I mean, so far, we've pinned down 22 different kinds of molecules, and they tend to fall into these major chemical families, like hydrocarbons, molecules made of carbon and hydrogen, and things called nitriles, which have nitrogen in them. And we're not just talking about some random chemical soap here. No, we're talking about specific, complex organic molecules. Things like ethane and propane, acetylene, the ring-shaped molecule benzene, and even the highly reactive hydrogen cyanide. Okay, so this is where it gets really interesting. All this chemistry that's happening way up high in the sky, it doesn't just stay up there. It actually reaches down and shapes the entire world below, connecting the atmosphere to the ground in this really remarkable cycle. These little molecules, they start linking up, kind of like Legos, getting bigger and bigger until they form these solid particles. And that's what creates Titan's famous golden haze. Eventually, this stuff just snows down, slowly blanketing the entire surface over millions of years. And at the same time, you've got gases like methane and ethane that get so cold they turn to liquid and literally rain from the sky. This creates a whole liquid cycle, with evaporation and precipitation that's just eerily similar to the water cycle we have here on Earth. This liquid methane carves out rivers and fills up lakes and these huge, vast seas. It's a landscape that's so alien, but also strangely familiar. But even with everything we've learned, especially from that amazing Cassini-Huygens mission, Titan is still holding on to some of the solar system's biggest and most profound secrets.
I mean, scientists are still grappling with these fundamental questions. Like, why is Titan the only moon that has a thick atmosphere in the first place? And just how complicated does all this chemistry get? Are we talking about the actual building blocks of life? Precursor biomolecules being formed up there right now? To get those answers, NASA is sending something straight out of science fiction. It's a mission called Dragonfly. It's a nuclear-powered quadcopter, basically a drone the size of a small car, that's set to launch in 2028. It'll arrive at Titan in 2034. And for over 3 years, it's going to fly from place to place, sampling the surface and giving us an unprecedented look at this amazing world. And here's the really crucial takeaway. Studying Titan isn't just some academic exercise about one weird moon. This research directly helps us figure out how to plan for future human missions that will go even deeper into our solar system. And all of this, it all leads back to the biggest, most tantalizing question of all. You have this world with a thick atmosphere, with complex organic chemistry, with liquid flowing on its surface. Could Titan, this cold, distant alien world, actually hold the secrets to how life itself got started? Not just on Earth, but maybe anywhere in the universe?